name is Ismael Marquez, and I am the Project Manager for Water Resources Engineering, or WRE. WRE was fortunate to have secured the contract for the Qualcomm Stadium Water Reuse project. Before diving into the project, however, I would like to introduce the team. WRE is composed of 6 engineers, from left to right: Environmental Engineer, Jose Alcaraz; Civil Engineer, Rob Lane; Environmental Engineer, Heather Tegley; Environmental Engineer, Fed Pinancos; myself, the Project Manager and Civil Engineer, Ismael Marquez; and Environmental Engineer, Lauren Miller. Qualcomm Water Reuse Project's main objective was to develop a conceptual plan that could be implemented as part of any future redevelopment of the current stadium. The conceptual plan has 2 criteria that must be met. 1 is develop an alternative water supply that could be used to offset the potable water demand, and 2, develop a water quality plan. Additionally, since the region has been grappling with a prolonged drought, water features developed as part of this plan will allow the city to illustrate the value and importance of water in the region. WRE vetted several plans, each unique in their approach, but settled on the plan presented on the next slide. In the conceptual plan, it has been assumed that any future development will include condominium high-rises and, as such, will require underground parking structures. WRE proposes incorporating a dewatering system that would capture the water and repurpose it for use as non-potable water. Additionally, the Serra Mesa watershed currently dispenses dry weather storm flow into the storm drain infrastructure located in the northwest corner of the property. WRE proposes capturing this water and also repurposing it for use on a future development as non-potable water. A microfiltration system will be used to clean the new water sources before storing it in an underground storage reservoir that will be detailed later in the presentation. The final component of the conceptual plan is an artificial river, an idea that has been floated around by various entities. The artificial river serves 2 purposes. 1, it will be a local attraction for businesses surrounding the river, and 2, it will offer the city of San Diego a venue from which to highlight the importance of local water supplies.
Hi, my name is Lauren Miller, and I'll provide a brief summary of our permanent dewatering system. Councilmember Sherman's visionary plan for the Qualcomm mixed-use facility leaves very ample space for WRE's water reuse endeavors. With this in mind, WRE intends to put a 40 million gallon water storage tank, which is about 450 feet in diameter and 40 feet high, underground to optimize the ground level area for the mixed-use facility. Oftentimes when excavating for a foundation, you may encounter groundwater. Now, for most, this could pose a problem, but WRE proposes to transform that problem into a solution. Based on some of the parameters from the geotech analysis, such as the hydraulic conductivity of the soils and the groundwater elevation, we will be implementing a permanent dewatering system consisting of 29 deep watering wells around the circumference of the tank to lower the water table approximately 15 feet, which in turn will produce a flow of 1.4 million gallons per day. The water table needs to be lowered by approximately 15 feet to alleviate any uplift pressure at the bottom boundary of our 40-foot high tank, and by doing so, this will enable a source of non-potable water. As you can see in the slide here, the tank will require 29 deep wells similar to that in the photo, and WRE has designed those wells complete with PVC well screen and casings, gravel pack, submersible pumps, control panels, riser pipe, check and gate valve assemblies, swing hoses, header and discharge piping, and electrical distribution cable. Once the system is complete and running, it will provide the mixed-use facility with 1.4 million gallons per day of non-potable water and could be potentially used for dual system plumbing and irrigation.
Hello, my name is Jose Alcaraz. I focused on the stormwater section for this conceptual plan. As you can see in this image, the Serra Mesa watershed runs off directly over Qualcomm. This makes it the most reliable source of dry weather flow. The Serra Mesa watershed provides a dry weather flow of 1.9 cubic feet per second. A comparable study from the Los Angeles Basin suggests that 192 GPD per acre is the average dry weather flow for multiple watersheds in the LA region. With a range of 190 to 320 GPD per acres, it is safe to say that our assumption of 190 GPD per acre is close to the average found by studies conducted in the southern watersheds found in California. As part of this conceptual plan, this dry weather flow will be captured and repurposed for use of non-potable water on a future proposed development. Given the prolonged drought in the region, repurposing dry weather flow for use is a growing trend and has been proven to assist in offsetting the need for imported water.
Hi, my name is Frederick Pinoncos and I'll be talking about the microfiltration component of this conceptual design. WRE plans to filter the water that is carried from the dewatering system and stormwater before storing it on underground storage tank. This will be done to prevent the contamination of the water and the accumulation of debris inside the tank. Our design system will use a pressure of 30 psi to push the water through membranes with pores that range between 0.1 to 5 micrometers. This will take away the bacteria and will effectively remove the suspended solids that cause turbidity in water. The microfiltration system will yield non-potable water suitable for a variety of uses on proposed development of Qualcomm Stadium. The microfiltration unit will be able to provide a total of 2.6 million gallons per day, which will go a long way in reducing the reliance of imported water.
Hi, my name is Heather Tegley, and I'm going to go over the conceptual plan for the storage reservoir. The capacity will be about 40 million gallons with a 450-foot diameter and 40-foot depth. The tank is designed in accordance with California Building Code 2013 and incorporates state-of-the-art features such as closed-tolerance electro-servo controlled wrapping, galvanized circumferential pre-stressing, automated shotcrete, vertical post-tensioning, and utilizes flexible connections at the wall base and wall top to improve seismic performance. All of these characteristics ensure this structure will last 100 years in the seismic region of San Diego.
Hi, my name is Rob Lane. I focused on the artificial river for this conceptual plan. The San Diego River flows along the southern perimeter of Qualcomm Stadium with a flow in the range of 5 to 10 cubic feet per second. This conceptual plan incorporates an artificial river that will use the San Diego River as its recirculating water source. The artificial river will then serve as a local attraction for businesses surrounding its path, as well as provide the city of San Diego a setting to highlight the value of the water through educational features along its path. The river will be pumped using heavy-duty low-maintenance slurry pumps. Each pump has a discharge capability of 3.5 cubic feet per second. Since the river will have a maximum dry weather flow of 10 cubic feet per second, up to 3 pumps will be required to reach the full potential flow of the artificial river. Each of the 3 main pumps will also have a backup in the case that a pump breaks or malfunctions, so 6 pumps will be required. As you can see in the chart, each pump has the capability of handling solids up to 1.5 inches. They are also capable of handling dry running conditions if there is any sudden decrease in the flow of the San Diego River.
It's Heather again. If this conceptual plan was implemented as part of a future development, it would add an additional cost of about $23 million, as can be seen in this table presented.
Hi, it's Frederick again, and I'm going to talk about the environmental impacts involved in this conceptual plan. First, I'm going to discuss air quality. This table presents the California Ambient Air Quality Standards and the National Ambient Air Quality Standards. As shown in the table, the San Diego Air Basin currently meets national standards for all criteria air pollutants except for ozone. It also meets the state standards for all criteria air pollutants except for ozone, PM10, and PM2.5. Another environmental concern is noise. Existing noise at the project site is primarily influenced by noise from vehicle traffic on the roadways adjacent to and in proximity of the project site, such as the Escondido and the Mission Valley freeways. Secondarily, from the noise generated by the stadium whenever there's an event. Noise may indirectly impact special status of avian species through disruption of breeding, nesting activities, and hindrance of local communication. An example of an avian species found around the area is this white-tailed cat. A total of 14 wildlife species were recorded to be found around the area. This include 1 reptile, 11 bird, and 2 mammal species. A total of 81 plant species were recorded in the project site, of which 35 species are native to the region. The majority of these species were detected or observed within their undeveloped habitats in the 500-foot buffer. Each of these species are listed and identified under WRE's Environmental Impact Report.
WRE set out to create a conceptual plan for water supply and water quality for the Qualcomm Stadium redevelopment. The conceptual plan incorporates creative approaches that will offset the use of potable water that includes a dewatering system and stormwater harvesting. Additionally, WRE has designed an artificial river that will serve as a local attraction for the surrounding businesses, as well as provide the City of San Diego a venue from which to highlight the importance of water in this region. If implemented, the stormwater flow and dewatering system will generate 2.6 mgd of flow that could be used to offset the demand of potable water. In conclusion, WRE's proposal is a standalone plan that could be implemented as part of any future redevelopment and offer the site a local water source that could be used for irrigation or possible dual-plumb buildings. As project manager of WRE, I would like to thank all of the San Diego State faculty that assisted the team, as well as our professional mentors. Thank you.